right, grade 11s, welcome to your Analytical Geometry series. We're going to have quite a number of lessons on this topic, and it's one of those easy topics where you should be able to score your marks well. So to start with, I'm going to remind you what you learned in grade 10 so you can make use of it in this video as well. So firstly, you learned your distance formula, and it is over here. Please notice how the distance between points A and B, if these were the coordinates of A and B, the distance was supposed to look something of this sort. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So really what you have to be able to do is to see your x1 and y1 and your x2 and y2. So for this particular first example, just so we can see if you remember these things, we're going to call these our 1s, and these ones we're going to call them our 2s. Okay, so if you see, I'm going to just substitute into this formula here. Please, I will not rewrite it, or maybe for starters, let me just do so. Please, this is the distance formula as you're seeing it in your formula there. It's x2 minus x1 squared plus y2 minus y1 squared. So you will easily calculate this distance by substituting in there. In this situation, we want to find the distance between these two coordinates A and B. So we want to know how long it is, this length of AB. So if I substitute, my x2 is -2 minus 1. Okay, let's square it. And then my y2 in this situation is -7 and then you say minus 4. So instead of saying minus 4, I can just write it as +4 and put it like that. So all of that you can just throw it into your calculator, or you can simplify it first if you want. Really, it's not exactly necessary. But let's go ahead. I'm sure that will be a 9 over here because it's -3 squared. And that one is also actually -3 squared. It's also another 9. So you seem to have a square root of 18 here, which if you want, you can simplify. Since it is 9 times 2, it should be 3 times 3 root 2 here, because the square root of 9 will simply be 3. So that's how long AB is this time around. So you could easily calculate it, the distance AB this time, by substituting into that formula. These are the things that you already knew from back then. So let's just make sure that you grasp the concept of this distance formula part. Let's answer the other one that is right there. The other AB, the second one. So I'm going to answer that with you. The second one for B, this was the answer for A, and you can do B just to check if you are. It's the second AB. I'm not going to rewrite the formula, you already know it. It's just that B is going to be my x2 and y2 now. So I'm going to say -6, -3, okay, and then we say plus, then y2 happens to be 3 there, -0. So it's just mere substitution into the formula. This, I would like to believe that you remember it from your previous grades. If not, here we are. Okay, that does look like 81 plus 9. So that's square root of 90. So I am going to just make sure that we change that one to 3 root 10, isn't it? 3 root 10 units. All right, like that. So please, people, this was the distance formula that you learned. Another thing you learned again in grade 10 was your midpoint formula. You did the midpoint formula, and it just looked like this. I have a feeling you are not able to quite see this, so just reminding you, it's like this. If you have 2 points, your 2 points should look like this, x1, y1, and your second point, let's say it was x2, y2, like this. So what we are saying is this visible? I hope it is. But if you cannot see that, the midpoint is simply going to be you adding these two x coordinates. Okay, it is x2 over there Okay, and then the y coordinate, you get it by adding the two y coordinates and dividing by 2. That is something you already know. So this is the formula that you have for the midpoint, and let's use it to calculate the midpoint of these two lines that are here. So we have this question here at A. You can see, in fact, let's see if we can enlarge that a little. Okay, I hope you can see clearly now the coordinates of A and B. So if I want the midpoint for the first one, if I want the midpoint, I am simply going to take that 1 and I add this 1 to that -2. The thing is, I will say plus minus 2. So instead of writing plus -2, I'm just going to write it as -2 because we know that plus times minus will just give us a negative. And then on the other one, it's -4 plus -7, which will just be -4 minus 7 over 2. Let's get the midpoint going for that one. 1 minus 2 is already known to be -1, so you put it over there, and then that should be -11, isn't it? -11 over 2. So let's put that one here as well. That is our midpoint for AB, for that line segment AB. On the other side, we can find the midpoint of PQ as well. So look at it. We substitute here. We add this one and that. It will be 3 plus -6. So I'll just write it like that. Okay, and then 0 plus 3 divided by 2. Getting the midpoint was one of the reasons we did so well in our lower grade, isn't it? It was just a simple task to do. And luckily for us, we are still going to use it now in this grade. So 3 minus 6 is still known to be -3, so it should be -3 over 2. And then on the other side, we still have 3 over 2. That should be the midpoint of PQ over there. It should be easy to see. Good. So let's carry on with this lesson and look at another concept that we learned back then. So another thing we learned a lot was the equations of a straight line. And for you, you knew the equations of a straight line because they were looking something of that sort. You will see that I use y is equal to mx plus c most of the times. So this one, it works exactly the same way, but you will see I don't really use it often. But whichever equation you decide to use, you will realize that both of them will require that you get the gradient first. You should still get the gradient first. After you get the gradient, then you can then calculate the c value. Well, so we want to determine the equation of the lines that pass through these coordinates. Okay, so again, I'm going to try and enlarge it. I hope it will be visible for you. Okay, so I think it is now. It is a bit better. So this coordinate, the coordinates that we have, it's -1 and -7, and this is -2 and -5. You know, we can actually try to draw it and figure out how this line looks like. So if I have -1 and -7, let's try to sketch this line. So -1 and -7, I may put it over here. Let me put it over here and say that point is -1. I'm just randomly putting it there. I have an imaginary Cartesian plane in my head, and then -2, I should go to the left. -5, I should go up a little, so it should be over there. So that would be -2 and -5. Okay, so we are saying that there is a straight line that passes through these 2 points, and we would like to find the equation of this straight line. Luckily for us, we can see it's slant to the left, so we are expecting the gradient to be negative already. So the first thing you have to do, according to the equation you are seeing here on top, this equation here, the first thing you need to do is to calculate the gradient of a straight line. So to do that, if you have forgotten, remember gradient is y2 minus y1 over x2 minus x1, like this. So it's very simple to substitute. You know what? I'm going to call these my 2's, so, and these ones will be the 1's. It will be x1 and y1 this side, and this one will be x2 and y2. So when you're substituting, you know what I mean. Okay, so in this situation, I'm going to say -7 minus -5. Okay, and then on the other side, x2 is -1 minus -2. As you can see, this gradient is going to be easy to find. The gradient of a straight line is simple to find, and on the numerator, it does look like we have -2 left, and it's +1 at the bottom. So the gradient then becomes -2. Well, once you have the gradient like this, what you can now do is to substitute it into the formula of a straight line, the general formula. Remember, the general formula of a straight line is y is equal to mx plus c. We're going to use that one more than the other one. So I am saying in place of m, let's put -2. So the equation of a straight line will simply be -2x plus c in this situation. Well, to get c value now, which is now the constant, the unknown available now, we have to put one of the coordinates. We just pick either one of these two that we're given. So I'll just pick, let us just pick, say, -1 and -7. It doesn't matter which one you pick, really. So in place of y, you put -7, and in place of x, you put -1. As you can see, you will easily find the value of c. So if you calculate -7 minus 2, it should be easy to find. Okay, so let's put our -9 over there. So the equation of this straight line, we have now managed to calculate that it is -2x minus 9. That is the equation of this straight line. That's one thing you were expected to be able to do, of course, in your previous grade. Good. So just to also have fun, just not to assume things, let's take this one, a line that passes through these 2 points here. I'm going to take the whole question, actually. Let's try to drag it down. I hope we're going to manage. Okay, so let's get the equation of a straight line that passes through this part here, which is called b in this situation. So we want to find the equation that passes through this coordinate over here, these two coordinates. Like I said, the first thing you do is you get your gradient. Now that you know it's y2 minus y1, I'm just going to go straight to the point. So 6 minus 2 divided by 1 minus 3, you should get the gradient very fast. That's like 4 over -2. It should be simple to see. All right. So after getting the gradient of that, it does look like we are working with gradients that are equal to -2 only this time around. I didn't do that on purpose. It just so happened that the gradient is -2 on both equations. Okay, so good. So we are going to substitute one coordinate to get c now. The c is the only unknown left. So to get it, you take a coordinate, one of the coordinates given, and then you substitute it in there. So in place of y, you put 6, and in place of x, you can put 1. And it should be very simple to see why the c value is easy to calculate. It should be +8 in this situation. So the equation of this line, as we have already established, the equation of this straight line is now going to be -2x plus 8. So we will expect you to be able to calculate the equation of a straight line in this series. That is why it was imperative that I revise that, so you don't carry on with this series without remembering that. Okay, so now one more thing before we go. You know that we learned of these perpendicular lines. In fact, let me just say a vertical line. Say we have a straight, let me put it like this. If I have my y-axis here, in fact, I wanted something of that sort, and my x-axis, let's say. So we've got our y-axis, and we've got our x-axis. These straight lines that we're dealing with, they were slant in some way. Well, they are lines that are either horizontal, or we can have a vertical line. we should also be able to remember the gradient of such lines. So when we say we have a line, let's say there is a line like this, a straight line like that, and there is a 4 here. So the equation of this straight line will be y is equal to 4. Y is equal to 4 everywhere along this line. But what we learned was that if a straight line is horizontal, if like this, the gradient thereof is actually going to be 0. So remember, the gradient of this line will be 0. So in place of y, you know, when we say mx plus c, if this part is 0, this whole part, I mean, if m is 0, this whole part is going to be 0. So you'll be left with an equation that looks like y is equal to c. It does look like my pen wrote E for you. Okay, y is equal to c. That will be the equation you get. That is why this is correct. This is the correct way of writing the equation of a horizontal line. Because m happens to be 0, this whole term falls away. So if I say y is equal to -3, that straight line will just be like this. And all it will be doing is to pass through -3. So the equation of this one will be y is equal to -3. And if ever I'm asked, I know that the gradient of this horizontal line will be 0. We also know the vertical lines, don't we? So a vertical line, again, if I may just squeeze it over here, let's say we have the y-axis and the x-axis like that. And if you want to have a vertical line, let's put it in red, like this. The thing is, really calculating gradient there is going to be an issue because on a vertical line, x doesn't change. The x value at this point and the x value at that point, let's just take it for granted that here it was 1 and maybe -1. And then here maybe it was, as you can see, it will be 1 maybe and +2. You see, the x value does not change. So if you try to calculate gradient there, in fact, you can go ahead and try it and see what will happen there. Let's remove this part. If I try to calculate gradient, here is what happens. You will say 2 minus -1. Okay, and then you go at the bottom, you will say 1 minus 1. As you can see, the gradient here will be undefined. So we do not even have a defined gradient for a vertical line. So if it's a vertical line, it is definitely parallel to the y-axis, and it has got an equation which starts with x is equal to a constant. Like for this one that we have, I can write it as x is equal to 1 easily. If I draw a vertical line anyway, let's say I draw it here, say on this one, and maybe this is -4, the equation for that line will be x is equal to -4. So if it is a vertical line, get it right, if it is a vertical line, it's x is equal to something. If it is a horizontal line, you write it and say y is equal to something. So you have it already here on your notes that I gave you, so please make sure to use it. Okay? Y is equal to k for a horizontal line, x is equal to k for a vertical line. Okay, let's quickly go ahead and see where this is applied. Okay, but before we do that, let's just answer this small question that we have here. If you're looking at this question here, it simply says we have to determine the equation of a line which is perpendicular to the y-axis. Okay, so we have the y-axis. I would like to just remove that. It's not working for me. Okay, so let me try again. We have, say, the y-axis and the x-axis. Okay, so we are told there is a line which is perpendicular to the y-axis and passing through -2 and 2. So firstly, I have to just say, to just approximate that, let's say we have a coordinate here, and that will be a coordinate. It's suitable, really. You can say that coordinate is 2 and -2. If I draw a line that is perpendicular to the y-axis, it means it has to be at 90 degrees to the y-axis. So that straight line may be something of this sort, passing through point 2 and 2. and perpendicular to the y-axis. If it is perpendicular to the y-axis, it means it's just like the x-axis. It's parallel to the x-axis. As you can see, it will be a horizontal line. So for horizontal lines, I hope you still remember it is the y value that does not change. So the equation of this line will be y is equal to -2. You give us the value of whatever that is which is not changing in that equation, in that line. Which makes sense if I ask you a question such as this. If it is now parallel to the y-axis, I'm going to use a green color. So if I draw a line that is now parallel to the y-axis, like this, parallel to this one, and it is passing through the same point 2 and -2. Please remember, what is it that does not change on a vertical line again? If you remember, I said it's x. So here the equation of this one is x is equal to whatever that value is, which is 2. Okay, try to swallow that as we use this information for grade 11 type of questions. In grade 11, however, you are expected to do something of this sort. Right, look at the lines now. You are to perhaps determine the points of intersection instead of just finding the equation of a straight line. They don't expect you to sweat as you find the equation of a straight line. So now they give you 2 equations mostly, 2 lines where you have to find a point of intersection such as Q. So what I must remind you is that you have to have the equations of both the lines and then you solve the problem simultaneously. So let's go ahead and calculate the equations of these straight lines that we have. So to start with, now we know that to get the equation of a straight line, we need to at least have its gradient. So you know the equation of, let me put it here if you forgot, m is equal to y2 minus y1 okay, let's try that again. y2 minus y1 over x2 minus x1. Keep referring to that formula right here, so you can see it clearly. So let's get the gradient of this line without any problems now. So I'm going to put these as our 2's and these ones as our 1's. So I'm going to say -1, -3 divided by 4 minus -2. So the gradient of RS will be easy to see. So go ahead, I'm sure you got your -2/3. There it is. So we now have the gradient of this line. So what we are left to do now is to put it into this formula, mx plus c. And then when we do so, we will find that it will be simple for us to solve. Let's make a bit of space. Okay. So look here. I'm going to substitute the -2/3, right? It's taking too long for others. And to get C, please notice I said get a coordinate that is on this line that we are finding the equation of this straight line here for starters. So get any point you want. So I'm just taking -2 and 3 for now. So I'm saying in place of y, put 3, and in place of x, just go ahead and put -2. Okay? Like that. So you should be able to find your C easily. So if you use your calculator wisely or even your good head, so this is +4/3, so you have to say 3 minus 4/3. That is what you're going to end up with. So as you can see, that will give you 5/3, isn't it? So definitely your equation now will look like this of the first line. -2/3 x plus 5/3. Like this. So we managed to get the equation of RS. Well, it's not the only line that's there. We also have to find the equation of TW. So to do that, we should also solve the gradient. Let's get the gradient of TW. But that one is an interesting one, right? We have T here, but it doesn't look like we have any other coordinate. But that is if you don't look too closely. Notice we actually have a coordinate 0, 0 that is on the straight line. So getting the gradient of TU, we are going to make use of that coordinate as well. So let's go and say negative 2 minus 0 divided by negative 2 minus 0. I am using the coordinate, the origin. It's passing through the origin, so there is no need for us to struggle with getting any coordinate on that line. So the gradient of TU, as you can see, is going to be equal to 1. If I substitute into this formula again, there is something more interesting about this line. Remember, C in this equation represents the y-intercept. That is the value of y. Okay, that is the value of y when the line cuts the y-axis, such as there. And in this situation, it's cutting the y-axis at y is equal to 0. So C in this situation is equal to 0. So the equation that is acceptable will be y is equal to x. Well, if you do not see it at first sight, just go ahead and substitute t into this equation. You will come back to this same equation. Right, now we have our two straight lines, the equations of the straight lines. So what do we use them for? In fact, we are going to solve simultaneously. So luckily we did our simultaneous equations well. Call one of the equations equation 1 and another one call it equation 2. All you need to do, we are going to use substitution. Let's make some space again. We're going to make substitution there. And we're going to say, let's substitute 2 equation 2 right into equation 1. That is what we're going to do. So we're going to say, in place of y, or rather, let's just go ahead. In place of y, we are going to put x. So I'm putting x right there in place of y. And then I'll have minus 2/3 x plus 5 over 3. So if I say 1 plus 2/3, it should be 1 and 2/3. And then you leave your 5 over 3 this side. Let's figure out quickly what that would be. Okay, good. So this is what is going to happen here. Okay, becomes 5 over 3x there. And definitely our x is going to be equal to 1. So it's easy really to see. And now that we got our x value, we can easily go back and substitute this one back there, you see, where we know that y is equal to x. So because y is equal to x, it means y should also be equal to 1 in this situation, which will leave the q coordinate as just 1 and 1. That must have been simple for you to find out. It's a good use of equations of straight lines, really. So after you learn all these equations of straight lines, you should be able to do something of this sort. So let's go ahead and do the second example. It's always powerful to do at least 2. All right, so here we have another example here. Luckily for us, this straight line is already given to us. Notice the equation is already here, which makes our lives very easy. So what we have to do now is to just get the gradient of GH and the equation of GH. Then we can see what to do afterwards. So I believe you can calculate the gradient by saying 6 minus 2 divided by 4 minus 6. It should be easy to see. So the gradient of GH here is going to be 4 over 10, which is going to just be 2 over 5. So I believe you've got that same one. Substituting it into y is equal to mx plus c, you should have this now. From what we discussed, you have to substitute one of the coordinates. So in this situation, you can substitute 4 and 6. So if you do this right, in place of y, you put 6, and in place of x, you put 4. So again, use your calculator to say 6 minus 8 over 5. Let's see what you get with that one. So I see that you got your C value as 22/5. Okay, so we seem to now have an equation which says y is equal to 2/5x plus 22/5. I know it feels like you should multiply by 5 everywhere, right? You can leave it here or you can multiply by 5. If you multiply by 5, this is what you will have. It will be 2x plus 22 left. So now remember, we have that one equation given to us. This equation up here, 3y is equal to 4x plus 16. We're going to solve those two equations simultaneously. So what I actually want to do is, because I know most of my students are good at substitution, I'm going to use that method first, and then I'll show you later how elimination can be used here. So the equation that was given to us was just this one, 4x plus 16. Let's call that one our equation 1. And this one, because we want to do substitution method, it would be wise to just leave y alone like this and make it 2/5x plus 22/5 and call that one our equation number 2. It appears as if I called both of them equation number 2. Let's call this one equation number 1. So if you're doing substitution method, all you need to do is to substitute this whole equation in place of y. So wherever there is y, you will put this whole statement over here. So it will be 3. Let me show you properly. So it will be 3 over there. Let's copy down the 3. And in place of y, I am saying put that 2/5x. That's substituting y with something, plus 22/5. And then you say is equal to 4x plus 16. Just the same way you did it before. Well, from here, it should be simple to figure out. So I'm going to just multiply 3 in. It does look like I'll get 6/5x. And 3 times 22/5, that's some 66/5. I hope you are getting exactly the same one. Yes, let's see if we are still together on that one. And as you can see on the other side, we still have 4x plus 16. Okay, so carrying on from here, what you need to do is to just make sure you calculate for x. So you can either take it to one side or the other side. It really does not matter. So let me ask you to say 4x minus 6/5x. You should get 14/5x. Okay, and then if I say 66/5 minus 16, you should be able to get minus 14/5. So by doing all this, you can see how x, you can just go straight to the answer here. If you divide by 14/5 both sides, you should be able to get x of -1. Not very scary. It's a good value. Or you can multiply by 5 everywhere first, then divide by 14 later on. It doesn't matter. So to get the y value, you can go and substitute that into that formula now. So you just go and say y is equal to 2/5. Let's put a -1 there and say plus 22/5. If you are right, you should be able to get your y value of 4. Okay, that's good. That was a good method to use the substitution in this situation. But I want to also help those people that do elimination, okay? So look at that part. I want us to use those equations that I put in that little box. They went too far away. So let's say we want to do elimination method, okay? If you do not like this method, you can as well just stop the video, because I think that is all we're going to do before we finish. So the elimination method is going to take these ones as they are. So let's say we have 3y is equal to 4x plus 16. Okay. And then this one, if I multiply by 5, notice it's going to be 5y is equal to 2x plus 22. Okay, looking at these two equations, you are seeing that no variables are the same. The y's are not the same, the coefficients are not the same, even the x coefficients are not the same as well. Look here, y is not the same, and even x is not the same, but there is a relationship between 4 and 2. So what we can do is to actually multiply this by 2. So if this was our equation 1, this is equation 2, I'm going to multiply the whole thing by 2 so we can have 4x there. Notice it will be 10y is equal to 4x plus 44. So to get going, I'm going to then say this is our equation number 3, and I'm going to use equation number 3 and equation number 1. So I'll just say equation 3 minus equation 1. So to start with, I'll say 10y minus 3y. That should definitely give us 7y. And on the other side, 4x and 4x will cancel. And 44 minus 16 should not be a big value. Let's just check that one. That should be 28. So as you can see, our y is going to be 4 as well, using elimination, right? And then to get to your x value, you can substitute into any one of the equations. Even equation 1 will work. So I'm going to say 3 by 4 is equal to 4x plus 16. So I believe if you work it out, 12 minus 16, there should be negative 4 here, and this is 4x. So definitely your x value is going to be negative 1. So there we are. So as you can see, it works all the time. So I do hope you enjoyed this lesson. Let's carry on and do more challenging aspects of the analytical geometry. Thank you.